Hello everyone, welcome back to my YouTube channel Neon Crackers for cracking IIT and NEET. So in the last class, in the last video we have discussed about applications of inductive, maybe plus I or minus I. What are the applications we have discussed? So carbocation and stability of carbanion, stability of carbon radicals. Next one is what? Acidic nature of carboxylic acids, acidic nature of alcohols, acidic nature of alcohols. So carboxylic acid comparison with formic acid is very important beta. Formic acid. So formic acid is here. Formic acid and one more acetic acid component. Acetic acid. Here a C double bond OH is there. Acetic acid. Now this carbon is connected with what kind of I effect? That is important. If it is connected with a minus I with a weaker effect, then the formic acid is more acidic than the acetic acid component. Okay, formic acid is more acidic, which means here what are the weaker effects? Means here it is connected, that X is connected. X is what? Minus, weaker minus A effect. Maybe it is hydroxy or it is NH2 or it may be what here? Not individual element. Next one is what here? C double bond C. Next C triple bond C. Next one more CC bond. Next one is what? pH. So like this, bonds are connected with this carbon, acetic acid. Second carbon, if it is connected with hydroxy, NH2, C double bond C, C triple bond C, C single bond C. Next one is pH. So actually practically all these are having minus I components because it is the last one, that is a group electronegativity or what? sp hybridization character. It is only complete positive charge and the partial positive charge, these two factors. And one more point, that 1 plus rule number 1 and 3, which means here partial positive charge with hybridization and sp character. That is only how a stronger minus effect, but that is what here. Cyanide is not there here, so this is the trend compared to what here? Formic acid with acetic acid of these components. Very important point, this one. Second one, opposite. Second one is what here? Formic acid is lower acidic than one type of carboxylic acid here, acetic acid of this. X is what here? A stronger minus I beta. Stronger minus I. What are stronger minus I here? Maybe NR3 plus because positive charge. Next one is what? NH3 plus positive charge. Next one is what? NO2 partial positive charge. Next one cyanide, also even cyanide because it is having partial positive charge with sp character. Partial positive charge with sp character. So in the presence of all these minus I effects, it is more acidic than even formic acid. See the trend, very important trend this one. Very important trend this one. Okay, very important trend this one. So comparison with respect to formic acid, acidic nature are there. Okay, so few more examples like alcohol. If we take here alcohol, what is the overall conclusion of the acidic nature? Acidic nature is directly proportional to stability of conjugate base. Maybe it is what? C minus, O minus or COO minus, whatever it is. So just simply remove the proton. After removing proton, we are getting what? Stability of conjugate base. That should be stabilized. By either plus I or minus I. So which is stable conjugate base? The respected acid is having what? More acidic nature. This is the acidic trend. Now if we take here alcohol here, one alcohol is there. Second one is same like here, one more alcohol is there like this. And third one is one more alcohol with extra carbon. Then compare the acidic nature order. Acidic nature is simply here what here? Minus, O minus. Of course, this is the alkyl group. Alkyl is nothing but what kind of effect? Beta here plus I. So now choose a DBN rule. Don't forget this point for alkyl. DBN rule. First distance. So this is the first one. Here also it will be first one. Now this is having two branches. Here two branches, right? Nothing. Then go for the next carbon, next distance. Here is the distance. Here will be the distance. Now this is having only one substrate, but this one is having two substrates. This is having only one substrate. So it is having what here? More plus side. More plus side. Total three components are there. That's why here this is having what? More plus side. Right? Is it clear, beta? This distance. First one same, two substrates. Second distance is what here? Two substrates, one and here one. So this is having more. Apart from now your branch, next one, next here carbon, next here carbon. This is having nothing. It is having extra methyl, which means here the second plus I component. The second plus I component. Here only a simple plus I. It is having simple plus I. Now acidic nature, stability. This is what carbon and O minus. So stability, what happened here? Negative charged particle. Stability is increased by electron withdrawing group, will be decreased by electron donating group, and this is the most electron donating. So stability, what happened here? Decreases. Acidic nature also decreases. This is the third one. Next here is the moderate second one. Here is the first one. So this is the acidic trend of alcohols. Check it better. This will be the acidic trend of alcohols. All are secondary alcohols. All are secondary alcohols. But depending upon alkyl group, of course, depending upon the position also, so it may be varied. So this is what here alcohol acidic trend. And with respect to hybrid orbitals, how to find hybrid orbitals? For example, if we have here what is a CH bond. Next second one is what C double bond CH. Next one is what here R C triple bond CH. Now compare the stability or acidic nature. So here remove the proton C minus, remove the proton C minus, remove the proton C minus. It is having what is the nature beta actually? sp3, and this carbon is having what? sp2. This carbon hybridization is sp. Now sp, electronegativity order. Electronegativity is directly proportional to S percentage of S orbital. Now which is having more S character? This is having more S character. So it will be attracted towards nucleus. What is happening here? Actually, what is happening practically? Electronegativity, how to find? So before going to discuss about this what here electronegativity, we must know what bond length. Bond length, what happened here? For example, if we take here S orbital is strongly penetrated towards nucleus. That we know already. Penetrating capacity among all the orbitals, S is greater than P is greater than D will be greater than what here? F orbital, S orbital. Now next one is sp hybridization. If we take here sp hybridization, so this is the P orbital. Now here S orbital is mixed. So this is what here sp hybridization. What is sp2? What happened here? P character increases. P is what here beta? P is what here? Dumbbell shape and less penetrated compared to S orbital. If P character is increased, now bond length is increased. Size of the orbital is increased. So this is the sp2 side practically. Compare here a pure S orbital, and this is what sp hybrid orbital. Of course, two are there. One I am taking. sp2, there are three. One I am taking. Next one is what here? sp3. P character is increased. Bond length, what happened here? Increases. Means orbital length is increased. The last one, pure p orbital if we take, it would be like this. Of course, it is here there. Same is there. But there is no space. Okay. Now see the length compared to from here nucleus. If you assume here from nucleus, so bond length, what happened beta, is increased. Bond length is increased. Length is increased. What is the length order? S orbital is having lower length. Next one is what? sp hybridization. Next one is what? sp2 hybridization. Next one is what? sp3 hybridization. The last one is what here? P. P. Now we are discussing what? Electronegativity trend. Electronegativity among hybrid orbitals. What is electronegativity? Electronegativity is nothing but if you take here two atoms which are connected in covalent bond, so the tendency of accepting BP electrons towards one of the element, maybe it is towards here, maybe it is towards here, that tendency is called here electronegativity. Better, that tendency is called what here? Electronegativity. The tendency of accepting BP electrons towards one of its nucleus, that is called what here? More electronegativity or electronegativity. Best example, if you take normally HCl, of course here hydrogen chlorine is having more electronegativity, which means these two bonded electrons are polarized towards, which means we cannot get here H plus Cl minus randomly, but here this bond is represented like this bond is represented like this. Now the most of the bonding electronic cloud is moving towards chloro because of En difference. This is having more electronegativity value. So that is what here electronegativity tendency. Now among these three hybrid orbitals, sp, sp2, sp3, sp is very near to nucleus, sp2 somewhat far away, sp3 is what here, sorry it is sp3, right, sp3 is what here, far away, distance is increased, then polarity towards nucleus what happened with that? Decreased. That's why among sp, sp2, sp3, which is having more electronegativity, sp orbital is having more electronegativity than sp2, and sp2 is having more electronegativity than sp3. So this is the order of the electronegativity that we can say based on what here s character, more penetrating capacity, so it is polarized towards nucleus, that's why it is having practically more electronegativity value. So this is the concept of En. This is the concept of En among hybrid orbitals. Now what is happening? What we have to apply this logic here? R Cc minus is there, Cc double bond, Cc triple bond. Now here more En difference, of course here sp and hydrogen is there. So this most of this negative charges, of course I am taking here some kind of positive nucleus. Now here negative charge is there, so it is having less bond length, and most of the negative charge is attracted towards what here? Nucleus. That is called here Z effective. Now in between positive negative, there are stronger attractive force. So what is happening here? Charge, what happens here? Charge of the negative charges decreased. Most of the negative charges neutralized by attractive force with respect to here Z effective nuclear charge. Now it is increased, but here charge is decreased, which means stability what happened here? It will be increased. So conjugate base of this one, stability of this one is more compared to this one. Next one, this one. So stability of carbonium, sp greater than, sp2 greater than sp3, which means here directly proportional to s character. If alkyne bond is stabilized, conjugate base is stable, then acidic nature is also increased. That's why what is the overall order here? RCCH lesser than RC double bond CH lesser than RC triple bond CH. So this is the acidic nature order. Is it clear? Better check it. This will be the acidic nature order for sp, sp2, sp3, sp, sp2, sp3. This will be the order. Okay. Now you may say here also stability of carbon, two factors are gone. Stability of carbon is directly proportional to S character. Electronegativity is also directly proportional to S character. The same way here also. Acidic nature among hybrid orbitals. Acidic nature, of course, acidic nature is directly proportional to conjugate base. So acidic nature is directly proportional to S character. Acidic nature, stability. So this is the application of one more important application of your inductive effect. And now one more important point is there. You may get shocked here. You will be surprised here. CF3 minus and CCl3 minus. Find out the stability order. Which carbonium is most stable? Whether it's what CF3 minus or CCl3 minus. What would be most stable? Right? What you guess? Your answer would be what here? F3. Why? Sorry, it is what? Fluoro is what? Stronger minus I effect, sir. It is having stronger minus I compared to chloro. That's why it is more stabilized, because carbonium is directly stability of carbonium is directly proportional to minus I. Wrong it is. Wrong it is. Absolutely wrong it is. One more phenomena is there. What is that? One more phenomena is there. So listen carefully here. Make it short here. C minus and fluoro. Next one is what? C minus chloro. Of course, here inductive effect. Which is having stronger inductive effect? This one is having stronger inductive. Fluoro, because both are elemental electronegativity. Fluoro is greater than chloro. Fluoro is greater than chloro, that we know already. So for example, if you guess here 100% negative charge, because of these three stronger, same distance. What is the rule? DNP rule. Distance is same. Next one is number is same. Next one, what is the priority? Which is stronger? F is stronger minus I. Okay, stronger minus I is present, and due to this stronger minus I, 100% negative charge is decreased to, for example, 10%, because most of the stronger negative charge is working here. Of course, here also, what is that? Minus I effect is there. So 100% negative charge to maybe 20% or 30%, because greater than this one. Why? Because it is weaker minus I compared to this one. That is okay. Here. According to minus I, CF3 is greater than CCl3. But the problem is what here? One more important factor is there. What factor it is? That is called, that will be what here? D resonance. D orbital resonance. What does it mean? D orbital resonance. Now here, that negative charge I am taking here. Of course, one chloro here. Negative charge is what here? LP. Next to this chloro. This chlorine is having, what is the outermost valency of chloro beta? Third shell, 3s2 3p5. Of course, 3s2 3p5 all are filled, but 3d orbital is present here. 3d orbital is present. So one of the d orbital is present here. Now this is having what here? LP. This is having empty orbital. So what will happen here? Partial overlappation between these two. Like this partial overlappation between these two. So these two are overlap. And forming one bond. That bond is what here? Pi bond. CCl2, 2 chloro same. Next one is C double bond Cl. Of course, after accepting, Cl gets negative charge. That is okay. Cl gets negative charge. But what we are discussing here? Stability of carbon intermediate. Now check it. What happened here? What is the charge of carbon? What is the charge of this carbon? It is 0. This is, of course, I effect limit. According to I effect, 20% only electron density, negative electron density is present. Of course, here also due to minus I effect, only 10% negative electron density is present. Only 10%. But what is here? What is this? 0. 0 means what here? It is more neutral and more stable, because neutral particles are stable. So now tell me, which is more stable here? CF3 minus or CCl3 minus? CF3 minus or CCl3 minus? So CCl3 is greater stabilized by D resonance than CF3. Very important trend. You may say like here, sir, exception condition, sir. This is not exception, yeah. It is not exception. Everything is conceptual only. We may not know about that one, but everything is conceptual. So it is having what? D orbital resonance. That we have to represent. Shortcut is what here? Dr, small dr, not capital Dr. Capital Dr is different. That is different. This is what small dr. D resonance. So in between now, compare. Of course, this D resonance is there. Now in between CCl3 minus and CBr3 minus, how to compare the stability? CCl3 minus, CBr3 minus. Of course, sir, here also it is having empty orbital, because there is no empty orbital. Fluoro valence is what? Beta second shell only. 2s2 2p5. There is no d orbital in the second shell. Here onwards, chloro 3s 3d and bromo next one 4 and 4d. Of course, here also d orbital is available. Here it will be d orbital. Then according to D resonance, both are getting neutral charge. Then which is more stable? How to find? Then we have to consider what here? I effect are what here? Yes. Here D is not working. D is not working because pi bond formation is exactly distance dependent. It should be depending upon what here distance. Why? What is happening here? CCl, if you take here CCl, now it is having one unpaired electron. It is having D orbital. Now if you take here CBr, of course it is having what unpaired electron. Next one is Br. It is having here 4D. Fourth shell D orbital, that is okay. Now distance is very near here. The proper orientation is there between these two. Now it is forming what here? D resonance. It is forming D resonance, which means the carbon is getting what is the charge here? Neutral. This carbon is getting neutral charge. Now here there is no proper distance to get overlap. Now see here, if it is coming like this, there is no proper orientation. So there is no formation of here D resonance or pi bond. D resonance we should not consider. Then what is the other effect? Other effect of Br is minus I. Now this is minus I due to minus I electron density from 100 to something but not 0. 100 to something but not 0. It is exactly 0. So which is more stable in between these two? CCl3. So what is the overall order? What is the overall stability order? First thing is what? D resonance. D resonance. This is Dr. Second one, there is no D in F, there is no D in Br, there is no D in iodo. Then what we have to consider? I effect. So according to I effect, which is most stable among fluoro, bromo, iodo? CF3 is greater than CBr3 minus, greater than CI3 minus. This is the stability order. This will be the stability order. Check it. Is it clear? Is it understood you? Check it better. Hope you understood it. CCl3, D resonance. Very, very important. Introduction of D resonance. Where we may observe this D resonance. One more shortcut I will tell you. D resonance. LP with third period element, which means any LP, carbonium with chloro, carbonium with phosphorus, carbonium with sulfur. Yes, you may observe this one. Empty orbitals are present here. Distance is a factor. Distance along with empty orbitals. C minus Cl, C minus P, C minus Cs. So these all are having what here? Dancing resonance. What is that? Dancing resonance. So based on this dancing resonance, one more application here, one more concept is being introduced here. We are just discussing only plus I minus I effect only. Extra point is introduced. So total 2 effects are over: dancing resonance and inductive effect. Okay. So this is the application of inductive acidic nature of alcohols or carbon bonds like double bond, triple bond, single bond. Next one, carboxylic acids. So one more application is left in inductive effect. That is what? Basic nature of amines or nitrogen related compounds that we will see. Okay.